Hello everyone, welcome to Raos Academy. Today we are going to discuss earthquakes, volcanoes and exogenic processes of geomorphic processes. First, in yesterday's session we have discussed endogenic processes. In that endogenic processes, we are in the midway. In faulting, we are learning earthquakes. After earthquakes, we are going to learn volcanoes. Important for your UPSC prelims 2026. Now, what is an earthquake? Earthquake is the shaking caused by sudden movement of rocks. Sudden movement of rocks along a fault due to plate motion. Yesterday we have seen faulting, right? Normal fault, reverse fault, strike, slip fault. Normal fault in opposite motion. In reverse fault, compression. Here a transform boundary in horizontal displacement. Plate motion. Because of the plate motion, at divergent boundaries, at convergent boundaries, at transform boundaries, you will see earthquakes. Earthquakes is the shaking caused by sudden movement. Endogenic processes, geomorphic processes, diastrophic, catastrophic we have seen, right? Under catastrophic or sudden processes, we have earthquakes and volcanoes. Earthquakes and volcanoes. Now, energy, where the energy is released near fault, inside, that point is known as focus. That point is known as focus of earthquake or hypocenter. Hypocenter. Focus or hypocenter. And nearest point on the surface above, that is known as epicenter. Maximum destruction you will see. When sudden movement happens, energy is released in all directions, and when first here energy is released and energy where the point it strikes first on the surface, that point is known as epicenter, near focus. Epicenter, hypocenter, clear? Hypo, inside, focus. Like this, waves are created, and those waves, because of sudden movement of energy is released, and energy in waves, P waves, S waves, body waves and surface waves. We have two types of waves, P waves, S waves. These are body waves, and other waves, surface waves. Body waves inside the surface, and those waves once they touch the surface, those waves are known as surface waves. Here, main types of seismic waves, we have learned seismic waves in internal structure also. These seismic waves help internal structure, density, regarding the material composition of interior layers of the earth. We have seen shadow zone of S waves and shadow zone of P waves. When geologists or geographers, they have learned about these seismic waves, S waves, they does not travel through solids. S waves does not travel through liquids and gases, they travel only through solids. S means solid, you have to remember, they travel only through solids. P waves, they travel through all three mediums, but because of difference in density, they refract. If a wave is coming like this, P wave, here liquid part is there, if it is coming like this, it will refract like this. It is going like this, it will refract because of the density difference, and because of that we see shadow zones. Shadow zones is the evidence that outer core is in liquid state. outer core is in liquid state. Seismic waves are the waves of energy caused by earthquakes or an explosion. They are the energy that travels through the earth and recorded on seismographs. What seismograph records? Seismic waves. Earthquakes are basically of two types, body waves and surface waves. Body waves, in body waves again P waves and S waves. P waves, in P waves you will see compressions and expansion. If you take a spring and you stretch it and you release, you will see compressions, right? And the direction is like this, and here compression, expansion, compression, expansion, compression, expansion, compression, expansion, like this, compression, expansion you will see. S waves, in S waves you will see crest and troughs, crest and troughs. To the direction they travel perpendicular, here they travel parallel, here they travel parallel, here perpendicular, like this. Surface is like this, they travel like this, perpendicular. Now, in surface waves also we have two types of surface waves, L and R waves, Rayleigh waves. These L and R waves are very destructive. Surface waves are very destructive compared to body waves. When they reach surface, destruction happens. You will see more destruction in surface waves. L waves, they travel like snake, horizontal. Now this is the surface, they travel like this, like snake. Now in S waves, you will see ups and downs, perpendicular, like this. In P waves, you will see like this, movement. In love waves, you will see horizontal, like snake. See, surface movement is like this, S, like a snake. In Rayleigh waves, how camel jumps, like this, like this. In elliptical motion, movement will happen like this. More destruction you will see. Now, types of earthquakes. Types of earthquakes. We have two types of earthquakes. First, natural. First, natural earthquakes. Next, man-made or induced, you can say. In types of earthquakes, you see tectonic earthquakes. Because of tectonic movements, you will see earthquakes. Sliding of rocks along the fault zones near plate boundaries. Those sliding, and because of that sliding, shaking happens. Those earthquakes are known as tectonic earthquakes. Next, volcanic earthquakes. Before we have seen in definition, because of explosion also you will see release of energy, shaking of earth. Because of this volcanic, because of volcanic eruptions, volcanic explosions, you will see earthquakes. Those are known as volcanic earthquakes. Now in man-made we have collapse, earthquakes because of mining. Next, explosion, earthquakes. Next, reservoir induced earthquakes. In explosion earthquakes, explosion of chemicals near nuclear for any test, nuclear reactor test or nuclear bomb, like that any test happens, because of those explosions, near that you will see explosion earthquakes. Reservoir induced, near construction zone of reservoirs. Near reservoir constructions you will see reservoir induced earthquakes, natural and man-made. Now, measurement of earthquakes. How earthquakes are measured? Based on the magnitude and intensity intensity. Magnitude scale means amount, how much amount of energy is released. Intensity, how much destruction happened. Intensity scale, it affects on humans. How much destruction happened. Now, how much amount of energy is released. How much amount of energy is released. Based on these two factors, earthquake, measurement of earthquake happens. Here, the scale which measures magnitude is known as Richter scale. The scale which measures intensity of an earthquake is known as Mercalli scale. Mercalli scale. One to 12 points. 12 means maximum destruction you will see. Maximum destruction you will see because of earthquakes on humans. Next. Now, seismic zone map of India. This map was given in 2002. About 59% of land area of India is liable to seismic hazard damage. We have 5 zones: zone 5, zone 2, zone 3, zone 4, zone 5. From zone 2, the risk increases till zone 5. When you reach zone 5, risk increases. In zone 2, low risk zone, blue color, here you can see, like some parts of Karnataka, Tamil Nadu, AP, Telangana, Chhattisgarh, here Odisha. Low risk zone 2, here also Rajasthan, Uttar Pradesh. Zone 3, moderate risk zone, here Gujarat you can see, Madhya Pradesh, here Uttar Pradesh, and some part of Bihar, here West Bengal. And zone 4, high risk zones. Zone 4 are high risk zones. Here complete almost, it covers northern states. Northern states, when you take Himalayan states, zone 4, it comes under zone 4 and zone 5, because continental convergence you see, right? Because of the convergence or convergent boundary, this area is liable to seismic hazard. This area is liable to seismic or earthquakes. More earthquakes you see in Himalayan zone. Here northeast, complete northeast comes under zone 5. Next, volcanoes. Volcanoes under endogenic process, sudden you see volcanoes. What is a volcano? What is a volcano? Volcano is a vent or opening, or an opening from where heated material or magma comes out. Magma, dust or pyroclastics, gases, very hot gases. Pyroclastics comes out. Magma. Asthenosphere, weak zone. Here magma, where you will find magma? Molten rock. Magma is nothing but molten rock in mantle layer. From here, because of this weak zone, it escapes and erupts on the crust. You will see this eruption, this opening or this vent is known as volcano. After erupting, this magma is known as lava. When it reaches the surface after erupting, we call it as lava. Inside, magma. Now, here magma is formed, magma travels, and after traveling, it erupts, it reaches the crust layer, upper part, and from there it erupts. All the processes from magma formation to its eruption, all those processes included, all those processes are known as volcanism. Under volcanism, all processes are included from magma formation till eruption. Eruption and solidification of rocks. Some solidification you will see inside the earth's surface also. You have both extrusive and intrusive landforms in volcanic. All those processes, all those landform processes, intrusive, extrusive, and magma formation, magma traveling, magma reaching the surface, all those processes include in volcanism. All these processes from where it comes out, that opening is known as volcano. And study of volcanoes is known as volcanology. Study of volcanoes is known as volcanology. Clear? Volcanism, movement and eruption of magma material from Earth's interior. Movement of Okay, magma formation. First, in magma formation, because of internal heat, rocks melt, and that rocks they form magma in mantle, and that rocks because of earth asthenosphere weak zone they escape, and from there they erupt. Under volcanism, you have two types of mechanisms. Endogenic and exogenic. Endogenic mechanism and exogenic mechanism. Under endogenic mechanism, you will see creation of magma, hot magma and gases, expansion and upward movement. What you will see here? Upward movement of this magma. Next, intrusive landforms or intrusive landform formations, cooling. Because this magma sometimes this magma cools inside the surface, and because of that you will see different types of landforms, different types of landform formations. Those are known as intrusive landforms because of cooling of magma inside. Cooling of magma before eruption, sometimes magma cools inside. Those landforms. All these processes comes under endogenic mechanism. When you take exogenic mechanism, process of eruption. Pyroclastics, and after eruption you see different types of geysers, fumaroles and other landforms, cone formation, dome lava, all those comes under exogenic mechanism. Volcanic activity based on mode of eruption. We have two types of volcanoes, effusive and explosive. Effusive and explosive. In effusive volcanoes, you will see slow flow. Lava flows slowly. In explosive, sudden explosion. You will see gases, ash, all those things, sudden explosion. Depending on the magma viscosity and gases content. If more gases are present in magma, it will be explosive. Based on the magma viscosity and gas content, volcanic activity you have two types, effusive and explosive. Effusive, slow flow; explosive, ash, gases, sudden explosion. Next. Now, types of volcanoes. Excuse me. Types of volcanoes. First, flood or Okay. Types of volcanoes. Volcano type flood or plateau basalt, very liquid lava flows very wide and it spreads widely, emitted from fractures. Columbia River Plateau, examples you can read in PPT here. Wide spreading. One fissure is there, no that volcanic shape you don't find, and from this fissure, this crack, the lava flows like this. Now, shield volcano, liquid lava emitted from a central vent. Central vent, large, sometimes has a collapsed caldera. Collapsed caldera in shield volcano, it is not that much explosive compared to caldera volcano here. Now, cinder cone, explosive liquid lava, explosive liquid lava, small, emitted from a central vent, if continued long enough may build up a shield volcano. Now, this is small. Now, volcanic eruption is continuous. This can build a shield volcano. Next, composite or strato. Wherever you see strato, strato means it is related to layers. More viscous lava and explosive debris, large, emitted from a central vent. More, wherever you see composite, think it is a complex and explosive. In stratovolcano, one layer of lava, one layer of ash, you will see like this, layers. From here eruption happens because of the ashes and gases present in that lava, in the magma, the eruption is explosive. Volcanic dome, very viscous lava, relatively small, can be explosive, commonly occurs adjacent to the craters of composite volcano. Near, like dome formation you will see. Caldera, very large composite volcano collapsed after an explosive period, frequently associated with plug. When a volcano erupts, because of the explosion, whenever any massive explosion happens in composite volcano, you will see destruction or collapsed of that crater. Now, this is known as crater. If it collapses, this is known as caldera. Now, we have two types of landforms in volcanic eruptions because of the volcanic eruptions. First one is intrusive and next one is extrusive. In intrusive, these are formed when magma cools and solidifies below the earth crust. Here UPSC may trap like this. Intrusive volcano means inside, right? They can ask about intrusive volcano. Here in place of magma they can give lava. Lava after reaching the earth's surface, right? Means wrong. Features: batholiths, massive irregularly shaped igneous rocks. Because of volcanic eruptions, what rocks will form? Igneous rocks, primary rocks formed from large magma bodies cooling deep underground. Here, deep underground. Next, laccoliths, dome shaped intrusions with flat bases that pushes overlying rock layers. Here you can see laccoliths, dome shaped. Next, lapoliths, saucer shaped. Laco, dome, lapo, saucer. Concave upward intrusions formed along weak planes. Here in diagram they did not give lapoliths. saucer shaped, P you remember, lapo, P. Phacolites, lens shaped small intrusions formed at the crest of an anticline troughs of syncline. Here you can see. You will see anticlines, synclines, right? Phacolites formed. Here, sills, thin sheet-like intrusions that solidify horizontally. Solidify horizontally along bedding planes. Here say, rocks are arranged in bedding. Here you will see sill. Now dikes, vertical or steeply dipping wall. These are dikes. Vertical. Sill means horizontal. Dikes means vertical. Next, extrusive. These are formed when lava, here you can see the word, lava reaches the surface and cools. First, cinder cone, small cone shaped hills made of loose bubbly volcanic cinders. Here, cinder cone. Caldera, a large hollow bowl shaped because of the collapse. Bowl shaped depression formed when a volcano collapses after a massive explosion happened. Because of this massive explosion, that crater was collapsed. Because of that collapse, because of that destruction, what happens? A large hollow bowl shaped depression forms, and sometimes in this depression water accumulates. We call them as caldera lakes. Fissures or lava plateau, vast flat and undulating surfaces formed by the slow continuous eruptions. Because of the slow continuous eruptions, we will see lava plateau. Deccan traps, best example, Deccan traps in India. Next, volcanic domes. Domes we have already. Now we will discuss few MCQs. First, which of the following statements about the focus and epicenter of an earthquake are correct? Focus is always located directly below the epicenter. Focus is the point where seismic energy is first released. Epicenter is the point on the surface vertically above the focus. Now, epicenter is a point on the surface vertically above the surface, not always vertical. Sometimes it may differ because based on the energy release, not always vertical. 1 and 2 is the correct option. Next, which seismic waves can travel through both solid and liquid layers of the earth? P waves only, S waves only, surface waves only, P and S waves. Solids and liquids, P waves. Surface waves, only solids. Next, the absence of S waves beyond certain angular distance from the epicenter proves what it proves. A. Crust is solid, mantle is liquid. B. C. Outer core is liquid. D. Inner core is liquid. Because S waves does not travel through liquid means it does not travel through outer core. It proves outer core is liquid. After that you will see shadow zone from 103 degrees to 142 degrees. Yes? Next, rift valleys are mainly associated with rift valleys. Reverse faulting, folding, normal faulting, strike slip faulting. Because of normal faulting. Normal faulting near divergent boundaries. Remember African Rift Valley, See, in reverse faulting also we will see valleys formation. Those are known as ramp valleys. But in some books they have given rift valleys all. They have mentioned rift valleys in reverse faulting also. So specifically, if they ask specifically about ramp valley, because of compressional forces you will see near reverse faulting you will see ramp valley. Rift valley mainly near normal faulting because of tensional forces, divergent boundaries. Strike slip, horizontal displacement. Folding you will see mountains, fold mountains. Faulting, wherever you see rift valley, ramp valley, block mountains, all these are related to faulting, not folding. Himalayas, folding. Block mountains, faulting. Now, which volcano type is built from alternate layers of lava and ash? Alternate layers. Layers means which volcano? Shield volcano, composite volcano or caldera or flood basalt. Composite volcano or stratovolcano. Stratovolcano is explosive. Caldera, depression because of collapse. Next, liquid lava flowing in flood basalt you see. Shield volcanoes are characterized by low viscosity lava, gentle slopes, explosive eruptions. What are the characteristics of shield volcanoes they are asking? Low viscosity lava? Yes, true. Gentle slopes? Yes, slowly. They flow slowly, because of that you will see gentle slopes, not steep slopes. Explosion? Gentle slopes means no explosion, right? Because of gentle slopes. Where you will see gentle slopes? Near slow eruption, effusive volcanoes, not explosive volcanoes. Explosive eruptions is wrong. So, if you take 3, A is the correct answer, 1 and 2 only. Next, which of the following statements is correct? All volcanoes occur at plate boundaries? No. Transform boundaries have frequent volcanoes. Divergent boundaries have volcanic activity. Earthquakes and volcanoes are unrelated. No, earthquakes and volcanoes are not unrelated. If you see plate tectonics, plate boundaries are related to earthquakes and volcanoes also. Because of explosive volcanoes, explosions, you will see earthquakes also, volcanic earthquakes. So, this is wrong. Divergent boundaries have volcanic activity? Yes. Transform boundaries have frequent volcanoes is wrong answer. Here in transform boundary, crust is not subducting any, compression is not happening or any, see in divergent 2 plates are moving away, magma comes out. In convergent, one plate subducts under other plate, and there because of that subduction those rocks melt, and from there you will see magma eruption, lava, volcanic eruption. But in transform boundaries they move in a horizontal way, no divergent, no convergent. Just those 2 boundaries say hello, hi, bye bye. So, you move like this, I move like that. So, no frequent volcanoes. Here you will see in transform boundaries, earthquakes. Frequent earthquakes you will see. All volcanoes occur at plate boundaries? No, all volcanoes does not occur at plate boundaries. Hotspots. They are not related to plate boundaries. Hotspots are formed away from plate boundaries. So, what is the correct answer? Divergent boundaries have volcanic activity. Now, which of the following correctly explains the absence of volcanoes along the transform boundaries? Just now we have seen Lack of earthquakes. If earthquakes are not there, volcanoes does not form. You don't see volcanic eruptions. No melting of mantle occurs or plates do not interact. Magma is too viscous. Magma is too, why they interact but they move in a horizontal way. No melting occurs here. Volcanoes finished, earthquakes finished. In next session we are going to learn exogenic processes about weathering, mass movements, deposition, transportation, everything, types of weathering, physical, chemical and biological weathering, even mass movements also, and again deposition also, erosion, and from those processes how different landforms are formed we are going to see in the next session. These are endogenic processes. Next, exogenic processes we will see. These endogenic processes, they create a stage. If you see volcanic eruption or earthquakes, they expose rocks, they expose primary rocks, and after that exposure what happens? In exogenic processes they perform on it. From inside endogenic processes, they are creating a stage for crust deformation. Now exogenic processes, now these exogenic processes they perform on it, and after performing what we will get? A landform through different geomorphic agents like running water, glaciers, wind, coastal landforms. You will see different types of landforms, means different agents create different landforms. All those landforms we are going to see in next session along with MCQs important for your UPSC 2026, UPSC prelims. Thank you.